let the people join in. That will take a couple of minutes. So I'll give one more minute and then we'll start.
Jaideep Da has put something in the chat. He has guests at his home, so he wants to speak early.
Okay, so that's fine.
Yeah.
So it's all we can switch that.
Thank you. Sorry,
Oh.
unexpected guests.
So Jaideep Da will put you at second. Is that okay?
Yeah, that's fine.
Okay. Sure.
Thanks.
Okay, it's recording. It's on live Facebook, and I see already we have attendees. It's 11:02. Good morning, good afternoon, and good evening, depending on where you are. Thank you for joining us for the webinar, very important webinar on third pole melting impacts and implication. My name is Soumitra Das. I am the president of Healthy Climate Initiative. I have the honor to make the opening remark. Before I begin, let me say a few words about why we are organizing this webinar. As you all know, Himalayan glaciers are melting at an alarming rate. The glaciers are melting so rapidly that the central and eastern Himalayas glaciers could disappear by 2035. There are 240 million people live in the Himalayan mountains and in the foothills. This melting is threatening their life. These glaciers feed 10 largest rivers in Asia, and nearly 2 billion people depend on these rivers for drinking water, agriculture, and hydel power. And 3 billion people consume the food produced in these river basins. The Himalayas is the fresh water tower for the people of 8 countries. Imagine the impacts the melting could have on these people. It could destabilize the whole world. This is not a local problem. It is global. And that is my takeaway from the UNDP report published last month. We organized this webinar to communicate the severity of the problem with the regional experts. We are also working on a proposal for field testing a technology solution that could potentially slow down the melting. We are fortunate to have Dr. Leslie Field, the founder and CTO, in this panel to say a few words about this solution. Let me say this. Although climate mitigation and restoration are the ultimate solution for climate, we need to go to net zero solution. We need to take out carbon dioxide to go to 300 or below parts per million by 2050 possible. But it will take several decades to achieve that. I'm afraid that we do not have that time. we need an interim solution to stop this melting and avoid the impending disaster. We have an exciting panel, and we have a great moderator, Mr. Rituraj Fukan. He is going to introduce you about the agenda and the speakers. Let me have the pleasure to introduce Mr. Fukan. Mr. Fukan is an environmental writer, adventurer, and climate change mentor based out of Assam, India. He is known as Assam's global climate change ambassador. He has been on expeditions to Antarctic and Arctic region thrice. Raj was personally trained as a climate leader by Nobel laureate Al Gore and was featured in the former US President's 2017 book, An Inconvenient Sequel, Truth to Power. He served the Climate Reality Project India as the National Coordinator for Biodiversity. Please welcome the panel and Mr. Rituraj Fukan. Over to you, Rituraj.
Thank you, Dr. Soumitra. And as you rightly pointed out, the future of nearly half of the human population on Earth hinges on the third pole or the water towers of Asia. We have Dr. Santosh Nepal as the first speaker, and his topic is the changing Himalayas, climate change and its implication on water resources in the Hindu Kush Himalayan region. Dr. Santosh Nepal is the group lead for the Climate and Hydrology Division of the International Center for Integrated Mountain Development, ICMR. He is a water and climate specialist responsible for designing and implementing research activities on climate change and water resources in the Himalayan region. In the last 15 years, he has contributed to scientific advancement in Himalayan hydrology and climate change. He has a PhD in mountain hydrology from the Friedrich Schiller University of Jena, Germany. He has also contributed to the special report of Ocean and Cryosphere of the IPCC as a contributing author and chapter scientist. Dr. Nepal is also a founding member of the Young Scientist Forum Nepal under the Nepal Academy of Science and Technology. Dr. Nepal has also contributed scientific publications in reputed journals, including Nature and Science. So over to you, Dr. Nepal.
Okay, thank you, Rituraj, and I would like to first thank the Climate Reality Project and especially Dr. Soumitra Das for this opportunity to share the climate change aspect in the Hindu Kush Himalaya region. Shall I share my screen? And
Yes.
I'll request Rituraj to confirm that you can see my screen.
Yes.
We can see.
Okay, you can see my screen, right?
Yes, perfect.
Okay, so my name is Santosh Nepal. I work as a climate and hydrology group lead in ICIMOD. ICIMOD is an international center for integrated mountain development, and we work for the Hindu Kush Himalaya regions in 8 member countries. The topic of my presentation is the climate change, the changing Himalayas, climate change and its implications on water resources of the Hindu Kush Himalaya region. So if you look at the Hindu Kush Himalaya region, it's actually spanned over 8 countries from Afghanistan in the western to the Myanmar in the eastern part, where in the HKH region, 240 million people live in mountains and hills. But if you look at the 10 big river systems which originates from the high altitude areas of the Hindu Kush Himalaya region, in the downstream areas, 1.6 billion people live. So, so this is how you can see that the importance of the Hindu Kush Himalaya regions, its biodiversity, its water resources, glaciers to the entire population. The HKH region has also the largest ice repository outside of the polar region. It has 60,000 glaciers and 6,000 kilometer cube of glacier ice. To put that in perspective, if you keep all the ice in the Manhattan area in New York, around 60 kilometers squares, you will see the tower of 100 kilometers going in the atmosphere. So that sort of ice mass that we are talking about. In all these river basins, which originates from the high altitude areas of the Hindu Kush Himalaya region, what we see is there is a very strong upstream downstream linkages, where you can see the glaciers like the perennial waters also from the groundwater resources, and then it passes through the midstream regions, and which is also called the transition zone, and then finally comes to the downstream areas in the floodplain region. So it's very much connected. So when river passes from the upstream and downstream areas, there are opportunities in the form of water availability, agriculture, irrigation, springs, the large, the irrigation issues. But at the same time, we also see the threats in the form of, the glacial lake outburst floods or flash floods or erosion and other kind of mechanism. So we all have been hearing that the climate change is affecting the different sectors in the Hindu Kush Himalaya regions, and there are a lot of studies, including the HKH assessment report, which was published in 2019, which has already indicated that in the region, the temperature would increase in the range of 2.5 degrees Celsius in the RCP 4.5 scenarios. And if the business as usual scenarios, the temperature could be higher the range that we're talking about. That's the whole global effort to put the the temperature threshold limits. Even if we are able to bring that 1.5 degrees Celsius, the 1.5 degree is too hot for the Himalayan region. So that is nearly half degree Celsius higher than the 1.5 degrees Celsius, 1.5 degrees Celsius elevation dependent warming. So what sort of impact we see from this kind of changes in the, for example, in the glacier? So again, from the HKH assessment report and some other report, it has very clearly indicated that in 1.5 degree, glaciers in the HKH region will lose 36, 1/3 of the glacier volume will be gone. In any case, that is gone, even if we are able to limit that to 1.5 degrees Celsius. But if we don't do anything, the tower that I told you, 100 kilometers, the 66 kilometer will be gone. So that will, the only 33%, 1/3 of the glaciers will be only remaining in the current business as usual scenarios. The implications of this kind of changes in the various sectors like snow-covered areas and snow volumes will be decreased. Snow melt, the induced melt runoff, and other kind of water availability will also be changing. I take you an example from the Mount Everest region, where luckily I had the opportunity to do my PhD, the snowfall patterns they will be decreased because of higher temperature instead of snowfall. More rainfall will occur, which you can see in the graphs. But at the same time, the melting pattern will also change. The snow melt will, the river will change. It's more or less like the fate, in the Himalayan indications. But overall, if you look at the river flow, there are indications that the increase in the increase. But then the studies also indicate that there will be too much water in some places and too little water.
Dr. Nepal, can I let me turn off the video for most of us? So if you can turn off, that could be helpful because the bandwidth may not be sufficient. So all the panelists can turn off the video.
Okay, thank you.
Sure.
So that means that what we are also, we need to deal with this extreme, the magnitude of floods. Okay. All this is also increasing disaster, if you name it, like flood, droughts, landslide, or glacial lava. Himalaya region, one flood, which are now the monsoon season is running, is also impacting a lot of people. But one thing I would like to bring to your attention is that the nature of the different disasters, which you can see in the recent times, if we name it Chamoli flash flood in 2021, this February, the Seti flood in Nepal in 2012, or Uttarakhand flood in 2013. All these are indicating the cascading disasters, which means that we are not one particular disaster. These disasters are happening together and they are amplifying the impact, which you can take an example of the Chamoli or other kind of flood regions. So to end, I would like to show these slides, which we call the HKH call to actions, which is the outcome of the HKH assessment risk report, which very clearly indicates that the urgent steps are required to sustain mountain environment and improve livelihoods in the Hindu Kush Himalaya regions. And we have proposed the 6 urgent actions. If I need to name it very shortly, we need to cooperate at all levels across the HKH region for sustainable and mutual benefits. We need to recognize and prioritize the uniqueness of the HKH mountain and mountain people at the global front. We need to take concentrated climate actions at all levels to keep the global warming to 1.5 degrees Celsius. We need to take accelerated actions to achieve the sustainable development goals. We have to enhance the ecosystem resilience, and at the end, because these impacts, the changes are not happening within the boundary, they are also happening across the boundaries. So we need to build that regional data information sharing and then the regional cooperation so that we all can deal these together. So herewith I will this is my short sharing. I'll hand over to Rituraj.
Thank you, Dr. Nepal. We apologize for the audio disturbances, but I think we could the message that you wanted to convey about the magnitude of the problem has been conveyed pretty well, and we will take forward this discussion with the other speakers as well as a Q&A at the end. With apologies to Dr. Fauzia, we will request Mr. Jaideep Gupta now to come in because he has a personal problem, and let me quickly introduce him. Mr. Jaideep Gupta is the South Asia Director and India Coordinator of the Third Pole and Internews Earth Journalism Network. He also trains environmental journalists and teaches environmental journalism at the O.P. Jindal Global University. He won the 2012 Green Globe Award at the Delhi Sustainable Development Summit organized by the Energy and Resources Institute. And he has also reported in the past for Indo-Asian News Service, the Statesman, the Sunday Observer, and the Sunday Mail. And we look forward to hearing the community stories of climate change in the Himalayan areas. Over to you, Jaideep.
Thank you, Raj. Hello, everyone. My job has been made significantly simpler and easier by Santosh. Thank you for that, Santosh, because he has explained the science behind what I'm going to say. So now, given what Santosh has been explaining, and which you can all see in detail on the HIMAP report of ICIMOD, let me talk a little bit about what this means to the people who live in the mountains. Now, most people who live in the mountains, the entire Hindu Kush Himalayas, most of them live up till a max of maybe 7,000 feet. That's about 2,000 meters or so. Very few people live permanently above 3,000 meters. Maybe they go there to graze their sheep or other livestock, and then they come down the slopes in the winters. So when we are talking about the water situation for the 240 million people, as Santosh pointed out, who live in the Hindu Kush Himalayas, we're talking about the water availability for people from the more or less the sea level till a height of somewhere between 2000 and 2500 meters. Where do these people get their water from? They live, most of them live on fairly steep slopes. Most of them do not live right next to the rivers at the bottom of the valley, because these are rivers that change their volumes very, very significantly in the monsoon and non-monsoon months. So it would be dangerous to actually live there on the riverside. So most of them live up the slope. Therefore, for their daily needs, for their household needs, these 240 million people are dependent on springs. Almost all of them depend on the springs that flow down from the hillsides and come out naturally. They tap these springs and they put some small pipes there. There are traditional ways. Kathmandu has lots of traditional ways of showing these of how these springs are there, and of course in smaller places you'll get a lot of them. And these springs are the lifeline of the people of the Himalayas. And what is happening due to climate change is that these springs are drying up. Climate change is not the only villain of the piece. Deforestation has a lot to do with it. And climate change has been a force multiplier in this destructive system. The result today is that for those of you who are from South Asia are aware that the monsoon months are usually June, July, August, and September. And that's when all the aquifers, the spring sheds get filled up. And people depend on this for the other 8 months. Now, as Santosh pointed out, winter snowfall has decreased significantly in the Himalayas. With the monsoon getting more erratic, we now have a situation where people often find that their springs are drying up by November. Sometimes they go on till December, which means they're left with the months of January, February, March, April, May, almost half the year, having to go down the slope to the river at the bottom of the valley where they live, get their water, sometimes twice a day. And this is something that has got serious gender implications because it's women who do this. It's women, and so for almost 5 months of the year, thousands and thousands of women who live in the Hindu Kush Himalayas are being forced to do back-breaking work in fetching water for the homes and spending up to 4 hours a day in this job. Well, you have to do it. You can't run your household without water, so somebody has to do it. So if there is no water in the spring at your village, then you have to go down the slope, often a half-hour downhill walk, and then an uphill walk with filled water cans. So you are carrying anything around 10 kilos of water, sometimes even more water, up steep hillsides. Can often take up till an hour. And you can well imagine that this has to be done not only by young women, it also has to be done by elderly women. So I have seen women in their 60s being forced to do this. And this, you can well imagine what this means for the people of the Himalayas. That's how important water is. Is there a solution? Yes, there is. There are some successful examples of spring shed rejuvenation in the Hindu Kush Himalayas. I know other panelists will tell you more about them, but I'll just point out one or two big examples. The best known example, probably, at least to my knowledge, is the example of spring shed rejuvenation in Sikkim. What they have done is actually theoretically quite simple. They have gone to the top of the hillside. So there is the bottom of the valley, which has got a river. There is the village about halfway up the hillside, and then there's the top of the hillside. They've gone to the top of the hillside. They've checked out where the natural underground, that is inside the slope of the hill, where the water channels are, and accordingly they have dug rainwater harvesting pits over there, so that more rainwater is harvested at the top of those natural water channels. And if you will find that people have now got water till March or even April, as a result of this, instead of till December or November. There are other excellent examples. I shall be very keen to hear about examples from other panelists, because we would like to report on them some more. Thank you very much.
Thank you, Mr. Gupta. It was wonderful to have you here.
Thank you, Joydipda. Climate change is a tricky story to wrap one's head around. It can feel too big, too scary, and too difficult for any one person to fix. Information, while important, is always not enough. For there to be engagement with this subject, and by extension political action, the climate crisis must feel personal, relatable, understandable, and most importantly, solvable. I think your presentation addressed all that. I myself have seen women in Nagaland carrying the water, and they really have a tough time. So moving on to our next speaker, we have Dr. Fauzia Taranum, and she will be addressing the topic that has been in focus today: water. Water, our worries, the Indian water crisis, current and projected challenges from glacial loss in the Himalayas, policy interventions, and community action. And let me quickly introduce Dr. Fauzia. Dr. Fauzia Taranum is an assistant professor in the Coca-Cola Department of Regional Water Studies at the Terry School of Advanced Studies. She is a recipient of the Fulbright Herbert H. Humphrey Fellowship and spent a year at Cornell University. She is also an awardee of the University of Nairobi IDRC Doctoral Research Grant. Prior to joining Terry School of Advanced Studies, Dr. Fauzia worked as a general manager sales at Cleantech Infra Private Limited, a company engaged in providing mechanized solutions for cleaning and dredging shallow water bodies. She received the Climate Reality Leadership Corps training by former Vice President Al Gore. Dr. Fauzia is a passionate climate reality leader and has conducted awareness and capacity building programs on water conservation, climate change, renewable energy, and gender equality, among others, for over 3,000 students, teachers, and youth groups in India. Over to you, Dr. Fauzia.
Thank you very much, Rituraj. That was a really comprehensive introduction. Thanks a lot. Good morning and good afternoon and good evening to all the participants and everybody present there. So the topic that has been told to me is about India's water crisis, current and projected challenges from glacial loss in the Himalayas, and the policy interventions and community action. A lot of it has already been spoken by Mr. Joydeep and Santosh. So I will begin with actually the India's water crisis. When I look at, I'll refer to the report by Niti Aayog, the Composite Water Index report, which was brought out in 2018. And there, they said that with business as usual, by 2030, the water available in India shall just be 50% of the total demand. Also, what we see is that the annual per capita water availability in India has reduced from roughly about 5,500 cubic meter in 1950 to about 1,350 cubic meter in 2021. So we can definitely say that India is water stressed. And of course, there are a lot of regions in India which are severely stressed, or even for that matter, water scarce. So India, of course, has probably the average rainfall is much more than the global average. But as rightly pointed out by Mr. Joydeep, that we have a unique season, what's called the monsoon season. So almost about 75% of this rain happens during the monsoon season. And because of climate change and global warming that we keep talking about, this period duration has shrunk and the intensity has also increased. India, of course, we have the water tower of Asia, the Himalayan region, and also we have almost about 20 large and small river basins, and of course, a large number of water bodies. However, the per capita water storage capacity in India is quite low. It's just about 260 cubic meter, vis-a-vis China, which is about 1,100 cubic meter, or for that matter, United States, which is about 2,000 cubic meter. India also has about 750,000 wetlands, which are there, but which is accounting for almost about like 4 to 5% of the total geographical area. But most of them have been either encroached upon or lost, though we have 42 wetlands which come under Ramsar Convention also. The problem is not, the water scarcity problem is not just about quantity, but it's also about quality, because we do have a problem of almost raw sewage discharge into our water bodies. 70% of our municipal sewage and 50% of the industry effluents go untreated into our water bodies. Also, we have high dependence on groundwater. So like in the Himalayan region, of course, when Joydeep spoke about the springs, they're actually groundwater. But we do have about 85% of the drinking water requirement, and 60% of our irrigated agriculture in India comes from groundwater. And there are more than 20 million private wells which are there from where this water is extracted. It's the largest user of the global groundwater, I would say. In fact, in today's newspaper only, I read that it's almost 1/6 of the groundwater in India is overexploited. Also, to combine it with cities getting concretized at a very fast pace, the infiltration rate has also reduced a lot, and almost 85% of water is lost either due to runoff or due to evapotranspiration. So that also results in reduced groundwater recharge. We did have a joint forest management initiative that was started in 1988. And while we talk about degradation of forest, and this was started with community participation, but we have had massive deforestation in the past couple of decades for mining and for infrastructure development. India is also among the top 5 countries in the climate risk index. And of course, the climate change will only be a force multiplier, will bring a force multiplier effect. Wetter regions are going to become more wet, and dry regions are going to become more dry. And we are actually already noticing this happen. In fact, Leslie is here. She would be talking about her Arctic project. But yes, India has a huge 7,500 kilometer approximately coastline. And our coastal communities are vulnerable to the sea level rise. A lot of it has to do with the glacial melting of glaciers. And this is resulting in saltwater intrusion into already stressed groundwater table. It's also resulting in soil salinity, impacting agriculture. as well. And of course, it's also resulted in a lot of increase in the frequency as well as the intensity of cyclones. We've already seen three of them very recently that has happened. And our cities like Kolkata and Mumbai are definitely amongst the top cities which are vulnerable to sea level rise. The climate change associated migration is already happening, and it is expected that 50% of the population in India shall be living in cities by 2050. I think Santosh really brought out quite well that ICIMOD report of 2019, which says that given the present levels of carbon emissions, the region could lose, the Himalayan region could actually lose as much as 66% of its snow and ice by the end of the century. I think both the speakers have brought out about the problems that it would cause to the 250 million people living in the mountain region, and also the downstream community who live alongside these glacial fed rivers, almost about 1.6 billion people who live there. Nobody has really actually done a proper counting of the springs, but again, the Niti Aayog report had mentioned about the 3 million perennial springs in the Himalayan region, and they said half of them have dried up or they have become seasonal. It's important to understand that these springs are also responsible for maintaining the environmental flow in both glacial as well as the non-glacial fed rivers through base flow. So that's getting impacted when the springs are drying up. And reduced flow in rivers are also impacting agriculture as well as the hydropower generation. And I think Joydeep has already brought out the reasons for drying of the springs. Of course, erratic weather patterns are there, degradation of forests, for schemes like hydropower and construction of roads, and seismic activity. Actually, what also happens is when we blast for these construction activities, they disturb the underlying geology as well, compacting the aquifers which actually feed into the springs also. The region has high dependency on the springs for drinking water requirement, domestic and agriculture water needs. And the studies that have been conducted in the Hindu Kush Himalayan region show a demand supply gap, which is roughly about 20 to 70%. And while it has been very succinctly highlighted that 6 months almost the region is water stressed, but there is a period where tourism is at its peak between May to July, and that further adds to the water woes of the region, the increased demand and high dependence on bottle and tanker water. So the tanker water mafia also is perpetuated in the process. The East Sikkim, of course, is fairly dry. The situation is alarming. Almost about 82.9% of the households municipal supply do not get any water in their taps during dry season. And people have attributed it to forest degradation, land use change in spring catchment, decreased rainfall, and increased number of dry months. So we have already heard about the Day Zero in Shimla, which was there in 2018. And the cause actually was that the state had 91%, 53%, and 67% precipitation deficiency for the months January, February, and March. So yes, both the rainfall and the snowfall has reduced also over time. And of course, the rich and poor divide. So who gets access to water when you are depending on tanker water and bottled water? The rich, of course, has greater access to water than the poor. I am not really touching upon the gender implication. I think it has been beautifully and very comprehensively covered by Joydeep, so I'm not touching upon that. But I'll definitely focus on the agriculture part of it. So farmers in the Eastern Himalayas and the Central Himalayas rivers, have reported rise in crop pests and diseases, leading to low yields, especially of cardamom and ginger. And that's attributed to erratic rainfall, droughts and floods, and higher temperature. In Central Himalayas, also the drop in the rainfall has exacerbated forest degradation and leading to more crops being devastated by wild animals, especially wild boars. I'll speak a little on the policy interventions. I'm sure you're aware of the National Action Plan for Climate Change that was brought in India. And this action plan has got a dedicated goal on National Mission for Sustaining the Himalayan Ecosystem. And this particular mission sets the goal to prevent melting of the Himalayan glaciers and to protect biodiversity in the Himalayan region. It's very important to see and look at the activities that have been undertaken by them. Then it has a goal on Green India Mission, which talks about afforestation. And then there is another goal, of course, on the National Mission on Strategic Knowledge for Climate Change, which is about knowledge creation. I would say that it's very important that we try and gather disaggregated data. It's very important to understand that who is getting impacted, how is that person getting impacted, why are they getting impacted, what are the programs and policies in place, and what are the benefits that is being derived by different sections of the society. So I think not just in terms of in terms of interdisciplinarity that I'm talking about, but I'm also looking at intersectionality that needs to be covered. And also there is a need to create an inventory of springs, and that can be actually done quite well with community participation, because the terrain is such that it's not very easily accessible to everyone, but the local people who have been actually thriving on those springs probably would be the best people to help in creating a good inventory of the schemes. And then we have the Jal Shakti Abhiyan, which also talks about the Catch the Rain campaign, which is there. It's happening right now across India and also in the Himalayan region, and it promotes rainwater harvesting, afforestation, revival of traditional water system. So a lot of things comes under the Jal Shakti Abhiyan. The Jal Jeevan Mission, again, which talks about providing 55 liters of water per capita per day to about 14 crore rural households, also talks about source augmentation. So that's another very important policy that is there, which can actually be leveraged to provide water. We have the draft groundwater framework bill. We definitely need a very robust groundwater policy. And this bill was actually brought in 2016, but it is yet to be enacted. It is in the draft stage. And here again, I would say that water pricing is definitely very, very important. And we need to really have right economic instruments in place. Community engagement, see, the solutions are local. So the problems are local. So the solutions also have to be local, and there is no one size fits all. And these are like socio-ecological, hydrological problems. So normally we do cover the hydrological and the ecological issue, but sometimes we miss on the social issues. So it's very important to engage community and the stakeholder. The top-down approach cannot work. In fact, I also wanted to speak on the Dhara Vikas spring rejuvenation spring in Sikkim, which already I think Joydeep has spoken about. It was implemented in 2008 by the Rural Management and Development Department, Dhara Vikas in Sikkim. And the objective was to engage community and for revival of springs. We have to also understand that springshed management is very different from watershed management, as springs, on one side of the mountain may have its recharge catchment on the other side because of the folds and faults in the mountain. So, we can't have the ridge to valley approach here. Rather, we need to go for the valley to valley approach when it comes to an understanding of the geohydrology becomes very, very critical. In the region, lots of households have started rainwater harvesting, water conservation methods, which are there. Again, we need to really develop a strong community-based water governance program, because a lot of these problems are not there because of physical water scarcity, but a lot of it has to do with economic water scarcity also, wherein we need to have, and poor governance. So we really need to have community-based governance, where involvement of women is crucial, because they have been custodians of the local knowledge, being actually daily visiting the source and fetching water from there. And it's also very crucial that climate change projections and impacts are also taken into account. There is a need for revival of traditional water management practices. We need to also focus on climate resilient agriculture. A lot of it has already started. Farmers in the East have developed new cardamom cropping systems outside forests to avoid disease. And they have changed the sowing and harvesting time of paddy, millet, and maize. They are actually dedicating larger area to perennial drought tolerant crops such as broomstick grass and cardamom. And they're also doing intercropping between food grains and vegetables. So yes, we do not have much time, as it was mentioned by Dr. Das in the beginning. We need to act fast. Thank you.
Thank you, Dr. Fauzia. Many of the things you have said actually resonates with me. Assam is known for its floods. It's a water abundant region, but many of the urban areas actually face water scarcity in the off season. So yes, a lot of issues that we need to discuss. Uh, Assam is also the most vulnerable among the 12 Himalayan states to climate change. So maybe we can talk about that later. Now we have a pathway to sustainable Himalayan collaboration, the possibilities of finding common grounds for solving issues related to shared resources between the countries of the Himalayan region. And Dr. Ram Bhuj, the CEO of Mobius Foundation, a New Delhi-based environment and sustainability think tank, will be delivering this presentation. He is also advising UNEP in developing a transboundary landscape conservation project. And prior to Mobius, Dr. Bhuj was with the United Nations system, civil society, government, and academics in senior supervisory positions for more than 3 decades. He retired from UNESCO in 2018 after serving the organization for over 11 years, providing intellectual, strategic, and operational leadership to its programs in South Asia. He was the secretary of the Intergovernmental South and Central Asia Man and Biosphere Network. He is a co-founder and executive committee member of the World Ocean Network, an active leader of the Global Forum on Oceans, Coasts, and Islands, a visiting fellow at the School of Natural Resources and Environment, University of Michigan, Environment Law Institute, Washington, D.C., World Aquarium, University of Bradford, UK. Dr. Ram Bhuj, it's an honor to have you here.
Thank you very much, Rituraj, for I think very detailed introduction. I think to shape the time, I would like to share the screen. Host has disabled screen sharing. There is some problem by the host.
You should be able to get that, Dr. Bhuj.
Yeah, okay. Now it's just enabled. So topic today, pathway to sustainable Himalayan collaboration. In fact, when Soumitra, you gave me this topic and I was wondering, then I realized, okay, throughout my career, I have been doing this collaboration, cooperation, and of course, networking. And I would try to hope to do the justice with this topic. Let me just put the full screen. Okay. Hopefully it comes. What happened?
It's the end of the slides. So you could go to the, yes.
Okay. It has come. And yeah. So actually the context is that my experience of over 3 decades in various capacities, first with the Northeastern Hill University, where I was basically involved in a work on ecological adaptation of forest ecosystem, particularly my work that was on the architecture of tree species and ecosystem, how they adapt to it according to the altitude as well as the climatic situations. Then, of course, there was another UNESCO MacArthur project on the cultural landscapes that was basically in Eastern Himalayas, and that too mostly in Arunachal Pradesh, and how these landscapes, they shape the biodiversity conservation, sustainable development in these areas. And with UNESCO, this Biosphere Reserve and World Heritage Program that was very much active, is still active in Himalayas. I was very actively engaged. As Rituraj mentioned, I was Secretary South and Central Asia MAB Network, a very dynamic network, and it has so many collaboration projects. And I was also basically for a very brief time for the 4th Third Pole Environment Workshop that was held way back in 2014. And there were a lot of things that we worked together: human-nature relationship in the region, climate change, past, present, ecosystem geology, and of course, there are two reports: that mass balance working group report and precipitation working group report. And currently, in fact, still I am engaged with this transboundary landscape in Eastern Himalayas, particularly Manas and Kanchenjunga landscape. Convention of Biodiversity, I think there are several regional initiatives. When India hosted COP11, and then there were several initiatives that were announced there. And particularly these are under these four conventions, you can say, international agreements: World Heritage Convention, which UNESCO monitors and controls; Wetlands Ramsar Convention, and Convention Migratory Species; and CITES, Convention on International Trade in Endangered Species of Wild Fauna and Flora. These are very important because recently this International Decade of Ecosystem Restoration have been launched, and all these kind of collaborations, they have become so important during this whole decade. As I mentioned, I was involved and still involved in this the Transboundary Landscape Project. In fact, that was on the behest of SARC. SARC used to be a platform. I think this is one of the most important platform that could usher collaboration in many areas. Of course, it's in a way politically it is defunct, but SARC Development Fund is very active. And on there, we have this project on transboundary conservation and building resilience in Himalayas with UNEP, ICIMOD, and GB Pant Institute. That project has been developed. But the most important aspect, because this involves 3 countries, and the country agreements are yet to be ready. These are very much intergovernmental processes, which takes a lot of time. So we are, in fact, in this collaborative program, we are struggling. South and Central Asia MAB network. This is basically 14 countries, a very dynamic network, and close to around 42 biosphere reserves and as many World Heritage sites, mainly natural World Heritage sites, that can provide a very good platform for many activities. To name a few, the Man and Biosphere Program and the World Heritage Sites, and they have advisory or technical capacity building, IUCN, UNDP, and many multilateral environmental agreements, including biodiversity liaison group. These are the platforms through which these 2 UNESCO designated sites they work. And of course, they also provide funding through bilateral, multilateral sources and private corporations. These were the 2 projects that were implemented under the MAP program in the Himalayas, this GLOCAMORE, Global Change in Mountain Regions. This was under the 6th framework of the EU with the University of Vienna, MRI, Mountain Research Institute, and UNESCO MAP. And this was followed up by GLOCAMOST, and this was again in mountain biosphere reserves from the Himalayas, Nanda Devi Biosphere Reserve and Sagarmatha. These 2 biosphere reserves and World Heritage sites were chosen under this program. These sites, they also work as climate change observatory. Many activities in many regions of the world, but including Himalayas, are being undertaken. And these are a few publications that have come out from these sites. Here are, I think, some sites you can see in India. There are 6 biosphere reserves. 4 of them are under the UNESCO's World Network: Nanda Devi in Uttarakhand, Kanchenjunga, Sikkim, Cold Desert, Himachal Pradesh, Nokrek, Meghalaya. Nokrek is very important because it contains a rare citrus sanctuary, almost, I think, richest gene bank of citrus is found here. Then Dibru Saikhowa and Dehang Dibang. These are the biosphere reserves. And then you have World Heritage sites, natural sites, 6 in India and 2 in Nepal. Unfortunately, other countries, they are in various processes of submission and of course subsequent designation. But right now only India, to some extent Nepal, they are into it. We are trying other countries also to chip in. Collaboration between people and the nature. This is very much there demonstrated in Nanda Devi Biosphere Reserves through the eco-development activities, where there is a kind of sharing of knowledge, information, as well as eco-entrepreneurship. A lot of traditional knowledge-based enterprises are coming up in these areas. These are conservation-linked livelihood initiatives. International Hydrological Program of UNESCO, it has certain programs, particularly in the high mountains. And one program that is very much, I think, active in Himalayas as well is International Center for Water Hazard and Risk Management, ICHAM. This is a Category 2 center based in Malaysia. And then International Center for Integrated Water Resources Management. And this is again Category 2 Water Center, which hosts Secretariat of Global Network on Water and Development Information for Arid Lands. And then International Network for Adaptation Strategies, which is undertaking this global project impact of glacier melt on water resources. This is financed by Government of Flanders, Belgium. Project developed the capacities of 235 participants from 19 countries of Asia, Latin America, and Caribbean. This is basically a capacity building project. Under the IHP, you can file several initiatives like Regional Glaciological Center in Almaty, Kazakhstan. Every year they do some of the meetings of the regional countries, as well as they do regional projects. Then working group on snow, ice and glaciers. And then high-level panel climate change impacts on water resource and adaptation policies in mountain regions. These are basically for the high mountain regions, particularly working the glaciers. INARCH is another network. You can find this to better understand alpine cold regions, hydrological processes, improve their prediction, and find consistent measurement strategies to develop hydrological models of different complexity that can support research in data-sparse mountain areas dominated by elements of snow, permafrost, and glacier cover. INARC was accepted by the Global Energy and Water Cycle Exchange Project of World Climate Research Program. This is a program under the UNESCO and many other UN agencies. And under the INARC basin, there are two, this China Upper Hai River in Tibetan Plateau and Nepal Langtang catchment. These two catchments are taken up. So this was all that I wanted to share with regarding the collaboration, regional collaboration, but there are plenty of possibilities that can happen in days to come. And I would be very happy to facilitate any kind of collaboration that this group would like me to take part or to facilitate. Thank you very much.
Thank you, Dr. Bruce. Appreciate the offer.
Thank you, Dr. Bruce. That was a very good insight about how collaboration could proceed in the future in the Himalayan region. Next, we have a potential solution to restore the third pole, a brief overview of the Arctic Ice Project's solution to restore the Arctic and the joint initiative to stop slow down the melting of the third pole with the Healthy Climate Initiative and the Climate Reality Project India by Dr. Leslie Fields. She is the founder and chief technology officer of the Arctic Ice Project. And Dr. Field is also an adjunct lecturer at Stanford University and founder of Small Tech Consulting. Her current work is focused primarily on Arctic ice restoration, which has a potential to be a key and safe lever on slowing climate change. And she has also shown keen interest in snow and glacial preservation as sea level rise and disruption of water supplies are critical problems facing humanity. So over to you, Dr. Leslie.
Thank you so much, Rituraj. And yeah, this has been a fascinating session. I have questions for a number of you when we get to the discussion session for sure. Let's see, can you see my screen?
Yes, we can.
Okay, super. So yes, thank you. It's an honor to be here. I've been working on a solution to ice melt, Arctic ice melt in particular, for over a decade at this point, with a growing cadre of people helping. And so we originally were Ice 911. If you're trying to look back in history, we're now the Arctic Ice Project. And what we're interested in is, can what we're doing help with glacial ice melt? And excitingly, some results we got just this last melt season on a freshwater lake in the US showed real potential for that. So we're very excited about that. So here we go. I'm not going to take you, I've got a relatively short overview time, so I'm not going to take you through an impactful NASA video that I like to show to people, just showing the relentless decline of bright ice in the Arctic and why that's been in a positive feedback loop that's very dreadful. But you can find it on our website, I believe. It's a NASA video. It's really attention getting. Of course, you've all been talking about other kinds of devastation that's really increased alarmingly and tragically in the Hindu Kush Himalayas region. Basically, what's happened in the Arctic is that as we've lost all this bright reflective ice we had only a few decades ago, all summer long we're absorbing more solar energy. And so this is accelerating heating of the planet. And I wouldn't be surprised if that were the case for the Himalayas as well. As you've been losing ice and snow, as you've been putting soot, depositing soot, I understand, just from the livelihoods of people there is not helping matters. I think this is probably also adding a loss of reflectivity that's probably accelerating global temperature rise as well. Peter Wadhams, a really well-known polar expert, estimates that as much as 50% we're adding as much as 50% acceleration, so 1.5 times as fast as we would have been without loss of reflectivity, to the rate of global warming, just from loss of reflectivity in the Arctic. And we've shrunk from about 30% of Arctic sea ice cover being bright to now 1%. We're very conscious that I'm a PhD engineer, I'm an inventor. The first thing I think of when I see a terrible problem is what can we do technically. But it's been very, very clear from the beginning that we have to help make sure that all the stakeholders are involved, so what we solve are the right problems and that we solve them in the right way. And so we have this, one of my colleagues, Danielle Chamberlain, put together this beautiful jigsaw puzzle way of putting together, we have to get this right. This is a picture of us working up in the Arctic, up in Utqiagvik, formerly known as Barrow, Alaska, as far north in the U.S. as you can go, with people who live up there, UIC Science, a native corporation. So it's a complicated framework, and it really is important to satisfy what people actually need and get, of course, the insights from people who actually live in an area that's challenged. I mean, you are teaching me so much today, and I'm going to be re-listening to this to be sure I got much of it. Here's our solution, our proposed solution. We've been working for a long, long time to answer a very simple question I'd asked which was, what bright, safe, reflective material might be used to help restore this lost functionality in the Arctic, to restore Arctic ice reflectivity, basically, and break the positive feedback loop. And basically our favorite material at this point is called hollow glass microspheres. You can see a lot about its characteristics there on the slide. And this is what it looks like as I'm just taking a bit of this little powdery material. So it's not a sheet. I know there have been efforts people have done on glaciers with sheets. I went through an early phase of trying sheets as well. They're really difficult, and I'm not sure there's been an effective sheet-like solution yet. But these little sort of floating grains of a very sand-like material look very promising. Everything, and first do no harm is our first principle. And so everything we've seen so far about it is very safe. but we're going to keep on testing, building collaborations with marine biologists, for instance, any local ecology groups that we could partner with in the Himalayan regions would be helpful, just to make sure that we are not doing anything that's adverse. What's nice about these materials is they're commercially available, they're widely used in many, many applications, and they won't bind with oil-based pollutants, which is really important if you're thinking about things that might eventually find their way into the ocean. And they're fundamentally a very thin, hollow shell around a gas core of a silica-based glass. They're amorphous, so if you're worried about, inhalation hazards, they're amorphous. It doesn't have those silicosis type of risks that you get from crystalline silicas. So it's a very safe material as far as we know, and we're continuing to test to make sure. If it turns out there's a need to pivot the solution a bit, find something slightly different, that's fine. We've got a lot of materials expertise on our team. We're in Silicon Valley. We're kind of used to pivoting if we need to. But so far, this is really our number one thing. And this is what we're proposing, really, is that we do a test to see whether we can preserve glacial ice. The idea is that on ocean ice, which is what we've been focusing on primarily because it's a big lever, we can change things that are open ocean, very, very dark. Young thin ice has more reflectivity than open ocean, which absorbs almost everything. If you put a thin layer of this material, Hairsworth's layer of this material on top of thin ice, it's instantly boosting its reflectivity. And over time, on sea ice, we could potentially regrow multi-year ice. I'm concerned to hear that you've got decreased snowfall, and I'm wondering if the soot situation has been improving with the adoption of brick kilns and such to replace a lot of these soot generating practices that have been necessary, right, to sustain life. So those are some of my questions for you, is would we need to, if we put a material like this out, would we need to replenish it continuously because there continued to be a lot of soot, for instance? So those are practical questions. What it looks like, this is up in Utqiagvik again, with another part of the UIC science team and with an instrumentation volunteer drilling for ice cores. And this is what it looks like on a Minnesota pond a few years ago. Really a fabulous test bed for us with some wonderful volunteers. You basically treat an area and then you leave control areas untreated, right? That's the whole scientific method. And we were distributing things in this small area by hand, square by square, making sure that we got even distributions. And the thing is, this really does boost the reflectivity instantly. And this past season, we had the most well-instrumented data set we've ever had. We also got these close-ups of, here's an area of bare ice on this pond, that same pond in Minnesota. Here's snow. You can't beat snow for reflectivity. Fresh snow is really great. And then the ice, that same bare ice that has a very low reflectivity, low albedo, when you treat it with these HGMs, with this, powdery material, this is what it looks like right here. And so instant boost of reflectivity. We got a lot of drone footage this year on that pond, and we have a lot of data analysis yet to do to spit out a number that we are very, very convinced about. But we certainly saw that we can preserve over the course of a season. It went this way. So test side, control side on that small pond from the air. There was some snowfall there too, over time, which accounts for why this is suddenly white. But what we got to see was a very substantial slowing of the melt for the treated area versus the test area. And we saw particularly that once the snow had melted, what we were seeing were these materials rising to the top of melt ponds and really just doing their work of being a high albedo surface, high brightness, so that the melt pond didn't accelerate melting at all. And so that's a very useful property, and that's why we think this is going to be very useful for glacial ice melt, land-based. So that's the question. Could glacial ice darkening, could glacial ice melt be reversed? Could the darkening be reversed by adding these materials? Can we slow the melt effectively? And we're excited that it really looks like this could be quite helpful. so far, everything looks safe, but again, we're testing. We're raising funds to try to get that marine biology collaboration going. They're ready when the funding's ready, and just really get the answers to, is this a good method to use? Preserving ice, of course, is, as far as I can see, one of the very key methods by which we can make a difference to slow climate change devastation in so many ways, right? This is one, a real humanitarian crisis of water going on in this region that we're discussing today. One of many terrible concerns, right? Sea level rise, heating, all of that. But this is one thing that could slow many of those humanitarian impacts and ecological impacts while we make time for the world to basically do job one, which is, my goodness, we have to shift our economies. We have to shift away from fossil fuels, and we have to rebuild that infrastructure. And that, as people before me in this webinar have been saying, that's a matter of decades, really, to make that transition. Even if everyone got serious about it today and made the transition as quickly as possible with an international collaborative effort, it still is going to take time. So we need some interventions in the meantime to try to limit the devastation to our ecosystems and ourselves and our future. So thanks very much. I look forward to lots of questions and interaction, and I love the offers for collaboration. There's no way we're going to get this done in time without that. And I just look forward to seeing whether we can help in this region in particular. Thanks.
Thank you, Dr. Leslie. I'm sure we have a lot of questions coming up around this very interesting technological solution that you have put forward. May I now introduce three of our eminent observer panelists. We have Dr. Mahendra Bhutiani, who used to work as a geoscientist in the DRDO in the College of Military Engineering before retiring as a director of the Defense Terrain Research Laboratory. He was also a speaker in the last webinar that we organized. Welcome, Dr. Bhutiani. And may I also welcome Dr. Parthojyoti Das, who is from Assam as well, like me. And he is the head of Water, Climate and Hazard Division and the Geospatial Technology Application Division of Aranyak. And then we have we have Mr. Aditya Bondir, who is the Director, South Asia and India of the Climate Reality Project. Welcome, Parthoda and Aditya ji, and we look forward to your observations, questions on this very important discussion. And we'll start with Dr. Bhutiani first.
Thank you, Raj, for giving me an opportunity to participate in this very wonderfully organized webinar. In fact, my question pertains to Dr. Leslie. Thank you, ma'am. It was a wonderful presentation. And thank you for suggesting a very novel way of reducing the ice melt by actually increasing the albedo of the snow cover. But my question is now, it's okay for on a small scale you can do it, but I'm really worried about the Himalayan mountains as such. Basically, the huge basins like Beas, Satluj, where snow cover is very fast depleting. Winters are reducing in their duration. And ultimately, there is a need to restore the snow cover there, as well as the small glacier that exist in Satluj, as well as basically the Beas catchments. So could you please sort of give us some insights as to how this technology can be sort of scaled up for larger Himalayan basins? And now I think this was my first question. The second question is like, now the time has come for us to take some active mitigation strategies to be implemented in the Himalayas. Now, I have been fortunate enough to work in DRDO, and at some of the ground stations, I worked in Himalayas like Manali, then Leh, then across Nubra Valley and all. So I can be a sort of catalyst in organizing experimental sites where the data can be collected with regard to the let's say carbon capture strategies, where you can have some carbon capture equipment now being manufactured all over the world, which can be installed at such sites in Himalayas, where actually we can think of some active mitigation strategies where carbon contained carbon can be captured, and along with this new technique of basically the silicon HGMs, I think we can go a long way in reducing the impacts of climate change in the Himalayas. Particularly, we can take up a small project in the Bias catchment, where we have got a very good infrastructure from my lab, where I worked as a director. And now question is basically with regard to funding. Is there by any chance a probability where we can get some funding where we can purchase some, let's say, carbon capture equipment and install there? Because DRDO per se doesn't act, or doesn't get involved in such kind of things. It is basically a defense-related institution, but we can co-opt them with my active participation. And if some funding is available from some agencies like Climate Initiative that Raj is heading, so we can take up such kind of active mitigation strategies in Himalayas. Thank you so much.
Thank you. Should I be trying to answer any of this at this point, organizers, or is this to wait for a general Q&A later?
So, Leslie, I suggest that you pick up the question that pertains to your area, that how can it be scaled up? So that's probably the question we should pick up, and then the rest.
So we have actually been studying how to deploy this. It has been, historically, we've been looking at how to deploy it for sea ice. And so we've had a nice team of students actually collaborating with us, looking at blowing it out of a blow stack with prevailing winds to help distribute it. It is a challenge because deploying by air is, this is a very, very light material, and you can easily fill up a hold, right? It's something that we need to continue to figure out. I'd say that is probably the most lagging of all of our technology proofs, is how are we going to deploy, especially on glacial ice, because this is a relatively new priority for us of, hey, it looks like there were terrible crises, Himalayas and Greenland, and then not to mention Antarctica, that could use some help. But we've been focusing on sea ice because of its incredible leverage. And so we'd love to take this on. Thoughts are about having cargo drops and drones and things like that, from that to distribute in the right areas. But there's a lot that would need, I think the initial steps are to do a reasonable scale test and just see whether it's beneficial. Get in with any biologists, ecologists that are concerned, that are looking at the kinds of things of, is there any untoward effect? I mean, silica is something that we all ingest regularly. We've got silica binders and my vitamins, blah, blah, blah. It's everywhere. It's in all of our ecosystems. But are these forms, these forms look safe. They've been tested a lot, but I really am serious about that first do no harm. So we need some collaborations to make, just somebody to assess, did anything bad happen in this relatively small area? Did it actually work? Did it actually help slow the melt? And this question about soot that I have, if there's an ongoing soot redeposition, how often would we have to replenish things? If there's not much snow coming in, is the decline from the rising temperatures just relentless? One thing that's very promising in our technology that I used as kind of a metric to sort out what materials might be promising at the beginning was that these materials allow you on shallow pools, at least, that kind of testing, to have the water underneath cooler. That was a critical metric for me. And so could we actually be slowing things thermally as well? Quite possibly. So there's a lot to be done. For sea ice, we've been working with an excellent team of climate modelers, Climaformatics, to scale, what our small scale interventions do on a larger scale. We haven't begun to do modeling on land ice yet, on glaciers, and that is probably very helpful too. On sea ice, we look for, is there a leveraged place? Can you deploy on a small area and have a larger beneficial effect? And I think we need to look probably for what are the key leverage points that would do the most good, the key areas that would do the most good in the Himalayas as well. You know, it's the only way I think to practically make this sort of thing work. So did that answer pretty much what you were asking? At least.
And I'll add a little bit to Dr. Leslie, that Dr. Leslie and us are working on writing a proposal to answer some of the basic questions on how we can tackle those, how to scale up, how to do the testing. So that's what we're working and trying to get funding on that and looking for the collaboration of Indian partners. We'll be looking for that, and we'll reach out to all of you in that sense, that if once we get the funding and positive things, then definitely we'll reach out to you on that side. Does it answer your question?
It answers my question partially.
Yes, and for your other questions, let us talk offline. I will talk to you about that offline. Is that okay? Okay, thank you.
I'm sorry to rush, but I think we are really running out of time. So Dr. Partha Das had a question, and I would also request the panelists to look at the Q&A if it is accessible to you, because I saw some questions directed personally to some of you. So if you could answer them in text, that would be fine. Otherwise, we will try to take them if time permits. Partha.
Thank you, Raj, for giving this opportunity to interact with the speakers. So far, it's been a very informative, very nicely conducted, presented seminar, and I have learned a lot. But I want to learn more, and therefore I'm putting a few questions. I have a couple of questions, but because of time, I'm putting one or two only. My first question is to Santosh, if he's there. Santosh, very nice presentation as usual. You know, have you seen from your work or from others' work in ICIMOD or for that matter for others, any relationship between the cryospheric changes that's happening in the Himalayas and the monsoons? That's my first question. Let me also put my second question. Is there any, reliable, quote unquote, reliable figures available for the rate of melting of Himalayas in general, and also for rate of recession of the glaciers? This question I'm asking because all of us know that about a decade back, there was a ruckus about a report being wrongly, included in the fourth IPCC document. It's a report about the rate of Himalayan glacier melting, which was erroneously kind of used. So therefore, it's always interesting to know what is the most recent estimate for Himalayan melting and glacier recession. Santosh, two questions for you.
Okay, thank you, Partha Das, and good to see you after a long time. Well, yeah. Well, I'll try to answer the first question, but it's a very technical question, and I don't have a very definite answer. But one thing which is coming very clearly is that the precipitation patterns which is changing, not only monsoon but also the winter monsoons, and then the on cryospheric side, the glacier mass balance things, that the consistent decrease in glacier mass balance throughout the Himalaya region, except some Karakoram region where there is a neutral or slightly positive kind of things. But on your particular questions, monsoon to cryospheric changes, I don't have definite answer. I don't know maybe the answer. The second, I couldn't understand the second question. You were mentioning about the rate of melting on glaciers, and can you please repeat the second question? Is it for me or for other?
It's for you only.
Okay, can you repeat the second question, please?
Is there any reliable figure, well accepted figure for the rate of melting of glaciers or rate of melting of snow and glaciers together in the Himalayas, or is there any quantitative assessment in general for most of the major glaciers as far as the recession is concerned?
Well, on the rate of melting of glaciers or snow, what is appearing, the last few decades is that the excess rate of melting, which is happening, and basically this is because of the temperature, the energy coming into the systems, higher rate of energy. We cannot find one definite, the rates for the whole Himalaya region because of the diverse climate and topography and other reasons. But what we are seeing more from the observation is that a couple of things I would like to point out is that, especially in the Nepal context, but we have been hearing from the local people that the snowfall is decreasing in the winter time. And it's also because the patterns are changing, but also partly because that the temperature has increased. So instead of snow, now more rain is happening because the temperature has already increased. If you look at last 40 years, around like at least in Nepal, more than 2 degrees Celsius has already been increased. So this is happening. And in case of glaciers melt, also what we have the definite answer is the mass balance, the negative mass balance throughout. But in terms of melting and then the river flows, there are some very few studies, but a very definite attributable kind of studies linking it to the climate change and others. I think we need more studies to establish what is happening throughout the Himalaya region. So Partha, it's not a very definite answer, but I tried my best, but maybe other panels are more definite answer. Thank you.
No, thank you very much, because your opinion counts. And if Raj gives me 1 more minute, I have another, I'm so curious to know, to what extent the RCPs, some of the RCPs and those scenarios you have also presented, I'm curious to know to what extent the RCPs or these models sufficiently capture the anthropogenic impact on climate, because climate change and global warming are themselves anthropogenic, but then other factors, for example, deforestation, urbanization, as Fawzia says, concretization, there are many other aspects of anthropogenic impact. Do these climate models capture all of them or some of them, or the most important ones?
Okay, Partha, is it for me or?
Yes, all my questions are for you.
Well, these RCPs are definitely considering the changes happening, but more in terms of the future increase in greenhouse gas substances, and then which is creating this the warming effect. And in earlier time it was more linked to the greenhouse gas emissions, but later it was more the representative concentration pathways, which is measured in watt per meter square in the the atmosphere, where the energy enters into the systems. This is one thing, and then these scenarios also definitely look at the other different kind of socioeconomic conditions, like the land use change scenarios or other kind of economic development. That's the reason that you cannot predict what sort of socioeconomic developments happening in 2050s, what sort of land use change, what sort of energy efficiency we would have. That's the reason that these RCPs give you the different scenarios, scenarios from RCP 2.0, which is like scenarios where these greenhouse gases, they start already decreasing, which is definitely not happening. Then you reach to the RCP 4.5, where like in 2030s, the peak of the emissions happens and then it start decreasing, for which we have a very limited time. And then there is the RCP 6, and then the last is the RCP 8.5, which is more like business as usual scenarios. That means that we don't have any energy efficiency technologies. We do business as usual, no improvement in the Paris Agreement. But there are improvement in the climate models, the way they represent the future changes, in the climatic systems. And then we have this new RCP, the new CMIP 6, the new models are coming, and there are also the SSPs the socioeconomic pathways coming. So combining this together give us, I mean, there's always a lot of uncertainty on this in climate change projections, which you can see from here and study, read in different papers. But we have to accept that uncertainties and then better understand these uncertainties when we do some assessments. Thank you. Thank you.
Okay, I fully agree with you. That was enough, Santosh. Thank you very much. Thank you, Raj.
So Mr. Aditya Pundir is actually looking after the climate reality project across all the Himalayan countries. So we request him to ask his question or comments.
Thank you, Rituraj. It was, I think, I'm really enlightened today. The experts came out with some very good thought points, I think, yeah. And we all know that climate change is happening, and we know that the third pole, this whole Hindu Kush area is getting badly impacted. So I will be very brief because I think we're really running short of time. Is that today is the World Population Day also. So you see the population of this region is increasing. But if you look at it from the perspective of the population of the countries in which they are part of, they are not much. So they don't have much of a voting, I would say, like political power. So what I'm really interested in understanding from the experts is that with this coming of climate impacts, which we know are there, what is your perception about how, is there any decent policy intervention coming in the hills? Because the money is limited for climate change adaptation. We know very limited money is available. Is that money flowing into the hills? And is it causing some sort of a solution-based thing for the future of the people? Because the population is definitely on the rise, even in the hills. So that's my worry, or I would also, my thought process is that, is there something happening to avert it? Because we know, and by the time probably we take an action, it may be too late. So that's my question to the panel. Anybody would like to take it up?
Yeah, I think that you raised a very important issue, particularly linking population with all these kind of sustainability issues. And I am particularly interested into this as today itself on World Population Day, we ran this on Z Network, sustainability. There is a mission sustainability population versus planet. So there was a full-fledged half an hour program. And particularly, this is a year-long program just to raise awareness. Regarding action, I think these are happening on many fronts. As one of this, Dr. Fauzia, perhaps she told about the Himalayan missions under the climate change. At least 3 missions are directly related to the Himalayas. That is one. And I think many of the Himalayan nations, they are part of the race to net zero. That means very robust program on renewables. 3-4 programs, the nature-based solutions, that means the greening and afforestation in those hills, that will the carbon capture mechanism. Then the other one is renewables at a very large scale. I think solar mission in the country is mountains are going to be the top priority. The third one is, of course, means like Bhutan is doing, is it has pledged the whole country, in fact, a kind of green country where for the entire, for days to come, it will remain almost 3/4 green, means around 75% green. And that will be the not only the carbon capture mechanism, but also a kind of market mechanism to earn carbon credits. And that will be, these are being worked out at various levels. So I think there are many options that are, but naturally problem is very, very gigantic, and we need very robust solutions and a lot of data support for that.
Aditya, I just wanted to add a few more sentences to what Dr. Ram has said. And a very important thing is we need to look into the hydropolitics and the geopolitics of that region, because we talk of 8 countries, but it's very difficult to bring them all together. So we cannot be looking at, this is my region, I will address this, because these mountains don't follow political boundaries. And it's very, very important to go for an integrated approach. I have attended an Indus Basin Forum at EC Mode. They're doing a great job, I would say, in terms of bringing everybody together. There is also a Himalayan University Consortium in India, which is there, which is of course promoted again by EC Mode. So a lot of efforts like this has been there, but we really need an integrated approach if we want to address the problem, and we are really serious about addressing. We do have, and besides that, the Springshed management program in India is being taken up in a very big way. So if you look at governments, also different governments, the Water Resources Department, earlier the way it was being taken, like the watershed management program, if you look at all the mountain states, you would see that they have, whether it's Uttarakhand or Meghalaya or West Bengal, or for that matter, even Arunachal Pradesh. And so they are actually focusing a lot on the Springshed management program, wherein they feel that that's another thing that would help towards groundwater recharge. Afforestation also as part of several of the government's abhiyan that is there. Again, it's very important to decide what we are planting. So you can't just randomly plant anything to create forests. So we say when we are planting lakhs of trees, we just randomly go and plant. So those things, I think native to the place is also very, very important what we plant. So many such things, sporadic things are happening. If you ask me, we still need to really consolidate and put them together and have a very focused and planned approach.
Thank you. Back to you, Rituraj.
Yeah, Soumitra, go ahead.
I'll have one question that came from Ron Swanson. And I think this is a very important question, form of a statement to some extent. So it's for all panelists. I'm deeply disturbed by statements which follow the typical IPCC pattern. By year W, with emission of X, we will see the temperatures of Y, and impacts will be Z. The IPCC framework assumption employs gratefully linear assumptions and gives false impression of high confidence. In reality, no one knows what nonlinear impacts we may encounter that may drastically accelerate impacts. We are seeing that now in the American West. What can you, all panelists, to alert people to the highly speculative nature of the IPCC conventional wisdom and frightful delays to action? Anyone?
Yeah, I think this is a complicated question. IPCC process, in fact, we all means it has brought science at the forefront of climate debate, and rather also the climate science and policy interface. So all these predictions, of course, these are proving to be real. The other thing is the action, delay in action, that's a political process. In fact, the Paris Agreement, in fact, was found to be not very adequate enough, because below 2 degrees is not going to help. It's below 1.5 or 1.5, and that is why this people are gradually graduating towards net zero and taking the pledges. Meanwhile, the nationally determined contributions of each country is one of the document which says his states, countries' pledge our readiness for action. So that is one. The other thing, I think there are activism, like I would say that the youth are at the forefront. They are forcing governments and many governments in the world to take action. So there are many fronts open, but definitely it's a very complicated to accelerate action. How this is possible? Of course, scientific, even IPCC and scientists, they have their own arena or their own, but intergovernmental processes, they are slow in a way, including the IPCC one. And policy matters, in fact, that needs a lot of noise, lot of advocacy, and lot of action on ground. So all these are happening in certain way. I am not very pessimistic about it, but we have to be optimistic as a, of course, believer in the future, for a sustainable future.
Thank you. Thank you.
Thank you.
Anyone else want to take it? We have
Dr.
very little time.
Santosh, Dr. Santosh has.
Yeah. Yeah, thank you, Soumitra. Very quickly, I mean, it's not only about the science, that we need to really have a good balance between the science pollution practices, that how much we can take from the science to influence policy so that we start changing our practices for the adaptations, mitigations, or resilient type of things. So that's where the entire cycle I see. And it's not about the only one approach, like Dr. Fauziya already mentioned about we have to have some kind of the integrated resource management, because we cannot separate water with the land or forest because they are very much integrated. While in the process, I think we need to give a very due consideration to the local and indigenous knowledge that we have already derived. That's where in some cases they were neglected. We have to build on what we already know, what our ancestors already know, and in terms of the knowledge that we have already applied. The last point is that I say it's a very difficult to differentiate between this impact is from climate change, and this impact is not from climate change. Take an example of the springs, which earlier speakers have also raised very strongly. But it is actually we have to look at the combination of non-climatic and climatic drivers which are putting pressure on our system. In springs, for example, there are a lot of if you look at the springs, a lot of impact is coming from the land use change, which is happening now. But there are speculations that because of the changes in rainfall regime, it will also impact. So we cannot just wait, that, and can't segregate that it is only happening with the one climatic driver. So that's where I think the entanglement of the non-climatic and climatic drivers is very important, so that we can put the problems together. And then to do this, because we're discussing the Himalayan regions, and I just want to reiterate what Dr. Fauziya mentioned, is that the regional cooperation is very important. Although we have a problem at the local scales, but for these problems, we have to have a regional cooperations, because what happens in the mountains, what happens in Nepal, that also affects in India, because it's connected. So I'll stop here. Thank you.
Dr. Bhutiani, quickly.
Just quickly, I appreciate the concerns by Dr. Fauziya. It has to be an integrated approach to solve the problem. But within our resources, particularly into consideration the huge expanse of Himalayas, can we take up one basin where all these studies can be carried out on an experimental basis? Like Bias, I mean, we have got the infrastructure there and it is accessible. Let's have this AGM technique being used, then carbon capture, then roofing techniques, and all these together. In what way they really affect the microclimatic of the basin? Do they really lead to lessening of the warming process? So I think one basin on an experimental basis should be taken up as an immediate thing. I think Dr. Fauziya has rightly pointed out in a very integrated fashion, so that the results that we obtain there can be subsequently extrapolated to the other regions. Thank you so much.
Thank you.
Thank you. Rituraj? Okay, let me thank everyone in the panel. We have taken more time than we, but it's such an important topic that we could not give justice just within 1.5 hours. So apologies for going over time, but also it is very important. I hope that you all get the severity of the problem, and I also hope that you will come forward to collaborate with us on the solution that the panel set. I'd like to thank everyone in the panel, Dr. Fauziya, Tarannum, Dr. Rambuz, Dr. Mahendra Bhutiani, Mr. Aditya Pundir, Dr. Leslie Field, Dr. Parthajothi Das, Dr. Santosh Nepal, and Mr. Joydeep Gupta for their wonderful contribution to the body of this knowledge. And we really got enlightened by this. I also would like to thank all the participants who asked the questions to make this program panel a success. We could not answer all the questions, but we still have the questions. I will forward this question to all the panelists for the answers. And if we have the answer, I'll forward them to you. Thank you very much. And we'd like to see you at the next webinar. Thank you. Good night.
Thank you. Thank you for this opportunity, Dr. Soumitra. Good night.
Right.
Right.
Good morning.